G'day Year 10. Today we're doing graphing polynomials. So the first one we're going to be doing is p of x is equal to 6x squared plus x minus 2. Now the fact that it says p of x, now that's exactly the same as if it had said y is equal to. It's just the polynomial x. Alright, so the first thing that we need to do when looking at a problem like this is we need to factorise. Now, for those guys who don't know how to factorise, you might need to go back and look at your textbook because it's very important here. Alright, so I've got 6 in the front, plus 1 as the second term, and minus 2 as the last term. Now I'm focusing on that last term. It's a negative, so it's minus 2. I'm looking for two numbers that multiply to give me minus 2, or just multiply to give me 2, that have a difference of 1. Two numbers that multiply to 2 that have, there's one thing I didn't look at, the fact that that's a 6 up there. So what I need to do is go 6 times 2, and that gives me 12. So this is actually a bit more complicated than I thought. 6 times 2, that's 12. The way that we factorise these ones, and it's a bit of a tricky one, we're going to write 6x squared, and we do something with that x. Now, two numbers that multiply to get you 12 that have a difference of 2, a difference of 1, that would be 4 and 3. Now, because 1 is positive, I'm going to write it as 4x minus 3x minus 2. And if you're wondering where I got these two from, it's because plus x. If you join these two together, it gives you plus x. Alright, now, because I've got it like this, I can factorise it pretty easily. I'm going to factorise the first two terms, so 6x squared plus 4x. 2 is a factor, as is x. And that leaves me with 3x plus 2. Close my bracket. Now, in the second set, I've got minus 3x minus 2, and I should be able to factorise that so as that it looks like 3x. So one of the factors should be 3x plus 2. And I can do that. I'm going to factorise it by putting a minus out the front. Minus positive 3x plus 2. Now, because I've got 3x plus 2 there and 3x plus 2 there, I can do a special type of factorisation where I go 2x minus whatever's at the front of the second set, and that's minus 1, bracket, 3x plus 2. Okay, so we fully factorised this polynomial, but the thing that we need to remember is that we're finding the roots. Now the roots are when, usually, another word for root is the x. Wait a second. Okay, so I'm going to write it as, sorry, I'm moving that stuff around. So I'm finding the x-intercept. Now the x-intercept occurs when y is equal to 0. Now I don't have a y, but I told you before that p of the x is exactly the same as y, so I've already factorised the polynomial. So when x is equal to 2x minus 1, bracket, 3x plus 2, close bracket, there are only a few ways that we can get this whole thing equaling 0. Remember guys, if this is equal to 0, the whole thing's equal to 0, which means the whole thing's true. So I'll do it the long way first. 0 equals 2x minus 1, which means that 1 is equal to 2x. And if I flip that around, x is equal to 1 over 2. Now that is 1 point there, a half, 0. The next one I'm going to do a bit faster, I think. So 3x plus 2 gives you 0. 3 is equal to minus 2. x is equal to minus 2 over 3, and that gives you the point minus 2 over 3, 0. Alright guys, at this point I need to draw your attention to the fact that this point and this point should belong to this polynomial. This is the point at which we pick up our calculators, type in the value for x, and make sure that when we substitute in the values, it gives us 0. If it doesn't give you 0, it means you need to restart or look over your work and find out if you've made a mistake. Now, I've already done that, and I know that it's okay. The other thing that I should be doing is I should be looking for my y-intercept. Now, the y-intercept occurs when x is equal to 0, and when x is equal to 0, y is going to be minus 2. So it gives me the point 0 minus 2. Now, we can start plotting. So if I go and move out a little bit out this way, I can start plotting these points. First point, a half 0, so I go from the origin across a half, up nothing. So my dot goes there. My next point, from the origin I'm doing minus 2 over 3, 0, so minus 2 over 3, and it's not actually on here, but minus 2 over 3 is about minus 666 recurring, so it's a little bit around here. And then I have my y-intercept, so it's at 0, minus 2, so at the origin, across 0, so on the line, down to, it's actually off the grid over here, so it's about there. Now guys, that tells me that it goes down like that, and up that way. And that's a polynomial.
I'm going to work out.
Okay guys, so that's it. Pretty much. And just remember that halfway between these two roots we have the point at which the curve actually turns or changes direction. Now that is what we call the vertex, and it occurs slightly over here about minus 0.08. That's it.